Good evening to our today's guest and today's session speaker, Dr. Rudra, sir, and good evening to all the participants. Here we are having our fifth day of the session, and our today's session speaker is Mr. Rudra Narayan Mishra. Sir is presently working as a senior mining geologist at Indian Bureau of Mines, Nagpur. Sir has completed the BSc degree in Geology, Physics and Chemistry from Ranchi University, M.Tech from Dr. Hari Singh Gaur Vishwavidyalaya. Sir is a member of Geological Society of India, Mining Engineers Association of India, Geological Society of London, as well as Geological Society of America. He has a certification in computing from IGNU, Delhi. For today's topic session, the topic is the application of AI and data science in earth science. So, I would like to request Sir to start with the session. So, Sir, I hand over it to you and thank you for your precious time.
Yeah, good evening to all. Thank you. Hi. My today topic is application of AI and data science in earth science. So first of all, in this topic, in this lecture, I will gonna cover the brief introduction about the artificial intelligence and data science and earth science. Then we will gonna discuss about the applications of AI and data science in earth science field. So artificial intelligence is the ability of a computer program to learn and think. John McCarthy coined the term of artificial intelligence in 1950s. He said every aspect of learning or any other features of intelligence can in principle be so precisely and described that a machine can be made to simulate it. And an
Sir,
attempt will,
sorry to interrupt you. Can we please make it in a
yeah,
slideshow mode?
sorry, can
So,
you hear me?
yes, sir, can we please make it in a slideshow mode?
Slide is not showing.
Slideshow mode, sir, full screen.
Okay, sorry. Just a minute. Yeah, now it's fine.
No, sir.
Yeah, now it's fine.
Sir, just we have to click the last one in as for a slideshow mode. In your PPT, the last one which is showing the icon, that one.
Yeah, can you see it now?
Sir, okay, sir, we can carry on.
Okay. So the artificial intelligence, nowadays we can't think about our life without artificial intelligence. In each and every aspect, we need the artificial intelligence. And John McCarthy coined the term of artificial intelligence in 1950. He said that every aspect of learning or any other feature of intelligence can in principle be so precisely and described that the machine can be made to the stimulative. An attempt will be made to find how to make the machines and use the language from abstraction or the and concept and solve the kind of problems and now reserved for the humans and improve themselves. The best example of artificial intelligence. What is the actually artificial intelligence? All the humans, what we have, that is the natural intelligence. So we have a different kinds of persons in the natural intelligence also. Like somebody is good in something, some is better, and some of the people are having a very good intelligence. The IQ level is very high. Same thing happened. Same thing is the replica of artificial intelligence. In the field of artificial intelligence, still we are using like Alexa, Google Earth, or self-driven car. These kind of things is a very initial stage, or you can say it's a early stage of artificial intelligence, because it's a single command. When we go for the multiple command, and the best part is that robot movie where we can see in the lead role by the Rajnikant, and he made the chitti. That is the when he is having all the intelligence, even only the thing he is lacking, that is the emotions. Once the robot got the emotions and we can feel in the artificial intelligence, that is the one of the best part. So the artificial intelligence is one of the fastest growing discipline in information technology. Along with the diversified data, AI-enabled technologies such as the image processing, smart sensor, intelli- intelligent inversions are being tested by the researchers in a wide variety of geoscience domain, and such as the geology, rock physics, seismicity, hydrogeology, ecology, marine geoscience, planetary science, environment, remote sensing, and GIS and related areas. The data science. Data science is an interdisciplinary field that uses the scientific methods of processing the algorithm and the system as extract the knowledge and insight form of structured and unstructured data. Data science is related to the data of mining and big data. Today, data science has overtaken a nearly every industry on the planet, and there isn't a single industry in the world now that isn't relent the data. As the result of data science has become a source of energy for business. The data science applications haven't taken on a new functions overnight. We can now anticipate outcomes in the minutes on which used to take a human hours to process because of the faster computer and the cheaper storage. We can think about earlier we are getting in the data science in the all the clumsy data when we have to be filtered, and the end product they demand one thing. So to process all the data within a time, we require the multiple data sets, and they use the faster computer and the cheaper storage size. The future-oriented questions are addressed by the data scientists. They begin with the big data, which are the three characteristic: volume, variety, and velocity. The information is then used to feed the algorithm and the models that the autonomously self-improve, recognizing and learning from their failures are created by the most cutting edge, the data scientists working in a machine learning and AI. The data science, often known as data-driven science, combines several aspects of statistics and computation to transform a data into the actionable information. Data science combines the techniques from the several disciplines to collect data, analyze it, and generate the prospective format and use it to make a decision. The data science, mining, statistics, mechanic, machine learning, data analyst, analytic, and some programming are the some of the technical discipline that make up the data science field. Now the earth science. Earth science is composed of mainly the four part, that the geology, geoscience, the study of the earth; oceanography, the study of oceans; meteorology, study of the atmosphere; astronomy, the study of the earth, the place like a space. We are a space science, we can say, or the universe. Now the artificial intelligence in the space science. Artificial intelligence is extend into the space. There are many applications of artificial intelligence in the field of space engineering and space technology. Artificial intelligence and machine learning can be used to simplify the operations of satellite communications. Artificial intelligence can help the human analyst to extract the maximum value from the imagery. AI and machine learning can be used to a new era of the space exploration, and AI help the double productivity. It has already played a significant role in the research into our planet, our solar system, and the universe. As a computer system and the software have it developed, so have AI potentials use the cases. There are many applications of artificial intelligence in the space, such as the mobile reconnaissance units, as the Mars Explorer. In the parallel with the scientific success of such robots in the cosmos, self-driving tractors or the cars by being developed by the back on the Earth, artificial intelligence play a main role beyond the mobile reconnaissance units of this kind. The self-driving units, such as the Mars Explorer, have achieved the major success with the important limitations, and they are restricted to relatively the smooth ground, and the use of insect-like robots would be considered as an alternative. The form relatively larger number of different projects space exploration contributes to the development of the self-driving vehicles on the Earth. While the development of the self-driving vehicles is the driving force between the research on the moons, Mars, and Venus. There is one example of AI applications in the ocean explorations. As we know, the 71% of the water is covered. Our Earth is covered with the 71% of water. So the mainly of the mineral resource, we are normally doing the exploration in the Earth side, but we have a use because of the Earth. And if your composition is the 71% of the ocean part is there. So the goal of development to implement a web-based decision support platform service to simplify and improve the exploration for a deep sea mineral resources. The concept of multi-data source, one platform, and the EO, that is Earth observation. So they are the agencies like the EO providers, like EMO Net, NOVA, and etc. So they are they are providing the Earth observation data. Then through with the help of AI and machine learning, we integration, normalization, analysis, and prediction and classification. These the integrated geospatial data intelligence we are using to the end product. This is the polymetallic nodules of exploration in a part of. This is the example of the Southern America, western part of the Southern America. So this is the polymetallic. The exploration and mining companies need to information or de-risk exploration and support the investment for the decision. The political and public administrative body need to inform and support the policies and regulations, maritime spatial planning, environmental impact, and attract the investment. These slides I just show for you the example. This is the basic things, the mineral resource and geological setup of the ocean bed. This is the topography of the ocean bed. Like when we start from the shallow depth, that is the water depth is less than 100 meter. There is the methane hydrates and phosphorite nodules. So these are the dotted, you can see in the continental slope rise part, there are the dotted. These dotted are indicative of the methane hydrates and phosphorite nodules. When we come to the abyssal plain, we can little bit mound is there. Sea mound place, there is a cobalt rich crust. So cobalt rich crust is having the depth of water depth is 800 to 2400 meter. Then we go for the manganese nodule, the abyssal plain, and that is these are the manganese nodules. The water depth is the 4000 meter to 6000 meter. Then we come to the mid-oceanic ridges and trench, island arc, and the back arc basin is the hydrothermal plumes. That is the SMS, seafloor massive sulfide deposits. And that depth is 1500 meters to 3000 meters. The approach through the AI and data science. The first approach is when in the previous slide, we can see all the signatures of like the methane hydrates. What is the signature of this? The cobalt and crust, the imagery signature is this. Manganese nodules and the SMS deposit signature is this. Through this, we have a different approaches. Approach through the AI and data science. So we have a different sensor type, primary observable quantity, derived variables, the multi-spectrum scanner, imaging spectrometers, then ocean color, chlorophyll, primary production, suspended particles, and bathymetric. Bathymetric survey, basically we use for the topography of the bed of the ocean floor. For that survey, we are using the bathymetric. Infrared imageries and radiometers, sea surface temperature, mixed layer temperature, surface temperature, then scanning microwave, radiometers, salinity, and the surface roughness. The surface winds and wave heights, wave spectra, the internal waves, then a scatometer and imaging and radar and altimeter, surface slope, geocatastrophic currents, ocean geodes, seafloor bathymetry, seafloor topography. All these are identification, all these are the work as a proxies. So identification of proxy first things, then second thing derive and the process data. After that, so when we derive and process the data, we can get the locations, abundance, and the grade of that particular minerals. Then data integrations and modeling and the prospective map. We are getting the prospective map to read about the geology, geological, geochemical, and geophysical data based on that. So we got the mineral occurrence, presence is there or not in the prospective maps. In this prospective maps, when we are processing that data, definitely we have to the proven occurrence. Where is the proven one? Then only we can apply to the artificial intelligence. Okay, this is the proven area, this is the unproven part. So both things are very important to identify that the confirmation of the proven occurrence and definition of the unproven targets. Like the red part is denoting the unfavorable, then yellow is the questionable, light green is the increasing, white part is the neutral, and the green one is the favorable part. So that similarly, the favorable part is the favorable part, like means the green color area is the low risk area, the neutral area is the moderate risk, then unfavorable is the high risk, and the red one is the very high risk. So the workflow for the successful artificial intelligence and machine learning applications, they validate the raw data, construct the robust and exploration model, they create and cluster the framework around the areas with the high information density, interpolate and extrapolate the data, create a training set, train and evaluate the model, validate the model, apply the rest of the data, and make the prediction. The implementation of proper data pipeline workflow of a successful artificial intelligence and machine learning applications. So use of the satellite-based and Earth observation data together with other techniques can provide the value-added information to the stakeholder involved in the deep sea mining sector, including the common citizens. The EO Earth observation from the space offer the easy, reliable, cost-effective way to capture the useful information in a particular in remote areas, as well as to develop a new product and service to support our global clean energy goal and boost the blue economy. To make this happen, we need to know more about the location and characteristic of the potential deep sea minerals deposit, as well as the environmental, social, and financial consequence of the potential extraction. Now we are coming to the what our government is doing for the initiative in the mining sector by the Ministry of Mines, Government of India. So they opt with the help of AI and data science. They developed two systems: is the mining surveillance system, where, as you know, all the mines are granted the lease area, and they're supposed to work within a lease area. If somebody is doing outside the lease area, then it's called the illegal mining. The term they use, the illegal mining. For that, the government of mines, Ministry of Mines, through the IBM, they developed the system is MSS, Mining Surveillance System, in the collaboration with the BISEC and the merit based on the space technology. Actually, this is the self-driven, you can say, the techniques they developed it. All the lease area, they already marked the coordinates. They given to the BISEC. BISEC plotted it, and every year they are taking the satellite imageries of that area. Twice, if somebody is going to outside the lease area, then it's automatically trigger generated. So the basic principle of the most of the mineral occur in the continuity, and their occurrence is likely to extend in this vicinity of the existing lease. The surveillance of the area is up to 500 meters outside the lease boundary and using by the satellite imageries. Before that, these MSS applications, the number of cases in 2009 or 10, it was reported somewhere 69,000. That is the illegal mining case, the major and minor minerals combined, reported by the state government. 69,316 cases. When these system applied with the help of you can say AI and data science or satellite imageries, the 40% case is increased because it helped to the state government to identify the DASI or area where they are not because of the human interference also. They are sometimes they reported some mines, sometimes they are not reported, but because of there is in this system like mining surveillance system, there is no human interference. All the satellite pictures are there. They have the data of lease boundary area. Outside the 500-meter area also they have the photographs. So if somebody is mining outside the lease area, self trigger is generated. So in 40% the area increase 97,149 they are reported by the state governments. Now this is the system Vizag. They are taking these yellow lines. If you see the yellow lines, that is the lease area of, and this is the structure that the image taken from the ISRO. And both the area process the georeferencing, the lease superimposed on the satellite scene. And the NASA Hyderabad provides the satellite scenes over a period of time regularly, and then finally it's triggered generated. So there is the height. This is the actually I want to see the I want to show. This is the red line. If you see total, this the blue line is showing violet color. It's showing the total satellite pictures area, the 500 meters outside of the lease boundary. So this is the 500-meter interval. They are taking the pictures of these area also. So and this is the red line shows the lease boundary. So the lease boundary, the mine owner is responsible to work only with this area. But also they saw in the image there are some mining activity, there are some digging activity. So what the MSS doing? MSS generate the trigger because this is the unauthorized activity is going on in this site, and they send to the concerned estate. And the concerned estate, they are sending to the state government officials. They are going to the field. They are checking the mines whether it is the uh, mines is working, or sometimes you know what happened when they are working for the road construction, the some other minor lessees they are working, but because of the image, the capture satellite capture the image of some activity. So for the ground truthing, it is important whether these leases are the for the same lessee or different ones. So only from the ground truthing it can be cleared whether it is the legal mine or illegal mine. But it is the system generated trigger. Earlier, what happened before 2016? This is the there is no chance of to. So every the state government officials have to visit the site. For them, it's also very difficult to go each boundary pillar corner to check and identify whether which part of the area they're inside the area or outside the lease area. It's very difficult to identify. But with the help of the technology, now it's very easy. And nowadays, it's very simple. Every year or every 6 months, we are getting the data from the satellite, whether these mines are automated system generated, triggers are generated and directly sent it to the concerned state government and regular its monitoring. So there is a very less chance of doing the illegal mining, and there is a huge penalty. So the mine owners are also very careful to not doing work even outside the area or tailing dams. They have to suppose keep all things like overburden, dumps, stack, mineral stack, everything inside the lease area only. Nothing should be go outside the lease boundary. Now there is a, this is the one applications. Next. Yeah, the advantage of MSS, like I say, the deterrence of effect, eye watching from the sky. So all the times, the now all the mine owners knows, okay, whether they somebody come for the inspection or not, it doesn't important because they are directly monitored by the satellite. So they always working within the lease area. Second thing, there is a transparency. Now there is no human interference, so it's a very clear cut or transparent. The participatory, the citizen can report unusual mining. That is the MSS is having also the app. So any citizen can take the photograph and upload the on the app. And that the MSS is also working on that. The bias free, no human interference. Like there is no involvement of any mining officer, inspector, or anyone. That is the total human, no human interference. Quick respond and action. The sensitive area can be monitored more frequently. If suppose some area is more frequent, the 2 or 3 leases are adjoining each other, and suppose someone make a complaint, then the frequency of imagery is more faster, or working is more quicker response and action in this side. Effective follow-up and action of the trigger and monitored through the dashboard. So these are the field verifications. This is the model of triggers they are generating. The name, suppose the category of mines. What is the valuation? If somebody is digging that mine, so how much quantity they extracted, that volume also can be calculated through this MSS software. And the unauthorized mining detected in the 16% case confirmed, and by the field inspection, like I told you, the first they do the field inspection, and then after they conclude, okay, whether it's mining is doing outside or inside, they only check by after the field inspection only. MSS trigger detected mining activity is more than 75%. The field verification of triggered by the state government officials. The nodal officer of the state for the MSS, the implementation of the follow-up. Normally, the mining officer is the nodal officer for each district. So they are the responsible to follow up all the generated triggers in his jurisdictions. The map for the mine or other lease improves the MSS effectiveness. Non-working leases of the major minerals, all the leases of the minor minerals in the vicinity of the major mining leases. Sorry. Yeah. Now the second advancing in this field, like first that is the satellite imageries. Through the satellite imageries, we got the triggers generated in the mining activity, and they control all the illegal mining activity. They check all the illegal activity in a within the lease area. Now it comes the second advantage of the drone and drone advancing in the earth science. So drone means the quantum leap for the surveying. Drone sends the data and cloud-based storage accessible to the authorized professionals, architect, engineers, geologists, contract, and the civil authorities. So earlier, whenever we are thinking in our mind, okay, somebody is having a mining lease, they are just mining anywhere. But nowadays, it's not possible because they have a very close monitoring through the satellite or through the drone also. With this year, the drone is also applicable for all the major leaseholders. Major leaseholders means when I'm talking about the major minerals like limestone, bauxite, iron ore mines, bauxite mines, all these mines are covered under the major minerals. So these mines are supervision by the drone. So use of drone technology for the sustainable and responsible mining. All these things are implemented, and these things comes under the rule. So all the lessees, they have to follow that rule. Because it comes in the Government of India Ministry of Mines has amended the Mineral Conservation and Development Rules MCDR 2017 in the year of 2021, the requiring the submission of digital image by the lessee, preferred bidders to the IBM, and the provisions of Rule 34 of MCDR. That is like in when we are doing anything like act and rules, we know the difference between the act and rules. Basically, all the act is passed from the both the Lok Sabha and Rajya Sabha, and after the act formulate, the act gives the power to the different ministry to formulate the rules according to the time or demand, something like that. So then Ministry of Mines thought, you know, now it's a drone. So they have developed the Sudur Drishti. Sudur Drishti means we can, without going anybody, or minimum governance, that the concept of our new government is the minimum governance, like very less manpower or interference of anybody, your mines can be inspected. So that they thought how we can inspect, how we can get all the data without any interference of any kind of inspector or mining officers to visit the mines. So they thought, okay, they developed the drone with the help of drone. So all the lessee has to submit high resolution geo-referenced ortho-rectified satellite images of lease area and up to the 100 meters of outside the lease boundary. Like in satellite imageries, what we are getting 500 meters. But in the drone, we have to restrict, okay, up to 100 meter. Within lease area, you have to submit all the information plus 100 meter along your lease boundary. So standard format is GeoTIFF, and with the and metadata and the other formats may be specified by the Indian Bureau of Mines in regards. The submit the process input the digital elevation model of DEM or orthomosaic. Like this, we can see the red part, that is the high elevations. This is the valley part. Some of the greeny area in this picture, we can see that is the plantation, or you can say the jungle part area, vegetation part area. The bluish is different textures. So these, suppose someone is having a lease, so they have to give the all these their topographical features, like where is the dump area, where is the mineral stack, where is the plant locations, where is the pit hole positions, and all these features they have to be given. And this activity they have to do every year. So 1 year, this is your position. Then next year, if somebody is saying I'm doing plantation, so you have to show the plantation also with these images. You can see that is height is also restricted up to 30 meters, something like that. Why drone? Because drone is faster. The 5 to 10 square kilometer yeah, can be covered in 1 day. And you can see this is the satellite imagery, and the other part is the drone. So drone part is very clear. We can see the each benches, the ramp. We can see the ramp. There are 3 ramps or 4, and this is the satellite imagery, very hazy. And the safe, there is inaccessible area and difficult terrain can be covered, accurate up to 200 data points per square meter with the XYZ value. So it's very accurate. 3D analysis and the volumetric calculation, stockpile dumps and elevation estimation. Traditional, this is the earlier total station or dumpy level or theodolite we are using for the traditional survey pattern. It takes months and months. So once of a year they have the force to do, but they are not willing to do all the time, because the for the big mines, if you visited like big mines like NMDC, SEL, Dalli Rajara mines, these are the very huge mines. So for them to do the traditional survey, it's a very difficult one. But now earlier it takes 6 months time to do the whole survey, but now it takes couple of weeks only for the drone survey with the data accuracy and all these things. So it makes faster. That digital data library, because it's very early now, we started just from this year 2022, because rules is already formulated in 21 itself. So this is our first year. So just you can imagine, in the first year we are getting all the mines data through all in all India level. So we have more than 1,000 mines data. So next year again we got the same kind of data. So our data sets will gonna more important. When we got the multiple data sets, then it's easy to data analyzing and using the AI and ML for the all these applications in the future prospects for our mines area. The cost effective, the value of money, as I told you, it takes earlier for the big mines like Dalli Rajara, it takes more than a month or months, 6 months, then it's too much costing for them. Now cost is very cheaper and require the less time, manpower, and low cost. Transparency, unbiased and precise data leading. There is no questions, because earlier traditional survey, maybe the surveyor is not doing religiously and he can just make it faster. But in this case, the drone survey, there is very transparent. You can see the raw data, image, picture, and all these things. So that is unbiased, unprecise, and leading the transparency to the system. Multifunctional, various type of sensors can be boarded as per the requirement. Like multifunctional role, the drone is the using RGB camera, different layers of the earth. These are the data output, orthomosaic map. These are the basic requirements of IBM, like Ministry of Mines. The each mine has to be submit orthomosaic map. Like you can see, the greenish part is the water body and the rest of the mines area. Digital surface modeling, like this. Digital terrain modeling, they have to give this. Point the cloud data, contour map, they have to give in the contour map, and different hyperstructure or lidar survey. If they want, they can use the drone, the magnetometer survey. The application of drone technology in the mining sector, like mines life cycle, exploration, development, production stage, and now the mine closure also. When you are planning to close the mines, you have to submit the plan, and accordingly again you have to do the drone survey to whether you fulfill or not. That we're gonna check it from there. So area of applications that the survey and exploration, mine survey, mines regulations, mine monitoring and safe mining practices. Like you can see, this is not the safe mining practice in this picture. This one is the safe. You can see the different bench and all these things in very clear. Mine planning, topographic mapping and contouring, magnetic survey, mineral identification using the hyperspectral image, topo map, contouring, generating the sections, preparation and scientific mine plan based on the accurate and orthometric image, stack monitoring and area volume calculations, haul road monitoring and planning. Because all these things also you can get in a video mode. So very easy to identify, okay, what we are saying. Also get the volumetric data, telling what is the status of telling dump slope, what they are actually saying. If you got the drone image like 2 3 years, there is no need to go and visit the mine. You can see all these things on your computer itself. The drone applications for the monitoring of the mine activity. This is the case study where you can see the loader and all these things. This is the dump site and drone is flying. This is the ramp. There is one bench, all these things you can see there. This is the boundary pillar actually, A65. If you see the A65, A105, these are the 2 points of the mine. So these are the lease boundary and they covered the more than extra 500 meters in this picture. Sorry, 100 meters. They have to cover the 100 meters. That part is not covered with the images because it's just the test run we did in the mines. The conclusion, use of the drone got the immense potential which can be automate the many of the data informations capturing activity in the entire life cycle of a mining project, which can be ultimately led to the sustainable, equitable and transparent operations, bringing a win-win situations for the both the miner and the regulator. The time series data over a period of time will gonna help we will gonna help a better data analysis with the application of AI and data science. The advantage of drone survey, like drone survey is the mining all these already I told you, like accuracy, the high resolutions images of the drone, the stockpiles are the regular positions or not. So drone aerial data and data generated over a period of time can be stored of the digital platform, time series and data can be compared. Because earlier in a hard copy mode, we don't have to the options to compare. But once we got the every year data, it's very easy to compare the profile positions and what was the proposal, all these things. This is the autonomous scanning for the underground mines and open cast also. So these are the applications for both mines. They have to be follow the rules. And it is compulsory. Like E3 and geoscience, AI data science of the virtual machine. The E3, they are the leading in the geoscience. They are using the maximum of the artificial intelligence and data science applications. The data science and virtual machines. So as I told, the ArcGIS, they have the big step forward for the advancing the visualization, analytic image processing, data management, and integrations. The ArcGIS is the best software for geologists are doing. ArcGIS Pro also installed in the data science virtual machine for the image from the Microsoft. The result of the collaborations between the two companies and will bring the AI, cloud technology, and infrastructure, geospatial analysis, and visualization together to help create more powerful and intelligent geospatial applications. The rise of the AI impact and the machine learning, like the generative designs, risk mitigations, and data platforms. The current state of AI in the engineering, the project schedule optimization can be considered the million of alternatives for the projects delivered and the continuously enhance the overall the project planning, image recognition and classification, enhance the analytic platforms, collect and analyzing the data for the sensors, understand the signals, patterns, deploy the real-time solutions, and cut across prioritize preventives, maintenance, and the prevent unplanned and then downtime. The new era of the emerge engineering with the AI tools is the terrain modeling, terrain evaluation. This terrain modeling is also important where is the landslides. When we are talking about the northeast side or the other seismic zones or landslide prone area, That is, terrain modeling is very important. Not only in the field of mining, that part is also very important. Terrain evaluation, design management, quality control, scheduling, performance, dashboard, field productivity, and robotic labs. Now we have in Chhattisgarh also one robotic lab from the all the samples without a human touch. Like when it comes to the conveyor belt, it directly goes for the uh, in different interval time of interval. They collect the robot, they collect the samples and they analyze itself. In Balada Bazaar, we have one lab with the having the Imami cement. Now it's New Vista. They are having a robotic lab. There is no human influence. A geologist can go through the app and he can check regular interval of sample analysis. Not so all these works with the help of AI. That is the importance of AI, artificial intelligence, reasoning, science, knowledge, learning, computer. These are the some of the using the machine learning through the satellite data and understand the changing of land use classifications. So there are the different, and with these basin, they are pattern designing the land use classification. The artificial intelligence is also locate the risk for the dam. Which area is risky? What is the silting position and all these things? There are the habitats and all these also they are using for the artificial intelligence. AI determine to whether these moistures or circulation like the meteorology, they also do the meteorological person or for the rainfall. Also we go for that. These are predict for the urban decade. These are the urban decades example. The AI analyze the satellite images. These are the satellite images like Google Earth. We can check it. Thank you.
Thank you, sir. Now I request participants, you can ask the question if you have any.
Yeah, if anyone asks questions.
Yes, sir. Nice presentation. I do have one query about this. Sir, as you are using this AI technology, okay, so those people who are working there initially, okay, before using this AI, so they are just losing the jobs, okay. So do you think that this techniques, whatever you have now used, they are just means degrading the people's job and all these things? I just want to your insight about this, sir. Hello.
Yeah. I just answered you. 1 minute. You
Yes,
see,
sir.
sir, as I in the very early slide I told you, we are in AI field. We are in very beginning stage. If we are when we are talking about like all the rules and applications comes in 2022 only applied in our side. So there is no questions about the losing the job because natural intelligence is the different things. We can't compare right now at this stage. We can't compare to the other developed country where there is a less manpower or something like that. Like very simple
Okay.
thing. If I'm right, you are talking about the losing the job and all these things, right?
Yeah.
The implementation of AI. So we are in very beginning stage. So there is no questions of losing the job for that because first of all we have to generate the data, and it takes at least 1 or 2 decades to generate the data and get the full confidence. With the help of AI, now what we are doing, we are grabbing the illegal mining. So there
Okay.
is no chance of losing the job. It's grabbing. You see the corruption, like the human interference. There is too much inspector. What is the inspector? The people are coming in your minds and asking questions whether you are working inside and outside. But with the help of these tools, you can easily identify. Okay, this is my area. I'm working within my area, and everything is transparent. So if
Okay.
you think about in this manner, these tools are like nothing like better than this.
Okay. Thank you, sir.
Thank you. So, any more questions? Very honestly
Any other
speaking, it's a
participants
learning
can?
for me also. So it's a thanks to the organizer to giving me
Thank you, sir.
opportunity on this topic.
Thank you, sir, for your valuable information in the session. and giving an overview of how the working followed at the Indian Bureau of Mines. We got overview how you followed the steps and how you identified the mine areas and allocating and reallocating that areas. Thank you, sir, for your informative sessions. Thank you, sir.
Thank you. Sir, may I quit now?
Yes, sir.
May I quit? Or
Yes, sir. Yes, sir.
yeah, thank you.
Thank you, sir. Dear participants, we'll start the next session at 8 p.m. We'll take a break of 15 minutes and we'll start the session at 8 p.m. Please with us. We'll start the next session at 8 p.m. Good evening, Prashanta sir. Good evening, Prashanta sir.
Good evening. Hello.
Good evening, sir.
Good evening.
Sir, we'll start at 8 p.m. sharp.
Okay.
Thank you, sir.